How are you? I am Mr. Krause. This is from MrKrauseMath.com. I am going to work you through the Algebra 2 Trigonometry, the New York State Regents exam in Algebra 2 and Trigonometry for June 2013. The answer keys are always online, but fortunately the answer keys really just don't give you the information that you need in order to solve and understand what it is you're doing. So I will take you through the solutions for this particular trigonometry final. It is absolutely in your best interest to attempt to do these problems before you watch this video. There is absolutely nothing to gain from just watching this video and copying down what I do like a monkey, right? I'm not a trained monkey. I am a mathematics instructor. I believe that if you're given the right tools, that you should be able to find solutions and answers to your questions, and for you to be able to look up these answers and solutions for your own. But if you're a juvenile student, an immature student that is unwilling to do the work, it will not help you on the Regents exam come June this year or next year or whenever you're planning on taking the test. So please do yourself a favor. Do the problems on your own. Attempt them on your own. Get frustrated on them on your own. That is how learning takes place. It only takes place through failed attempts, and then you figure out things. Okay? So if you want to just check your answers, check your answers. If you'd like to just go through this video and enjoy my ranting and raving and bantering and whatever the next word is, go ahead. But I will take you through all of the solutions of all the problems, and in some cases I'll take you through multiple solutions of the same question. To do this, I will be using the TI Nspire software as well. If you don't use this calculator in your classroom, it's relatively similar to the graphing calculators, TI-84 and things like that, but this one has buttons in different places. So I'll be using this one because this is what I use in my classroom, and I do not have the emulator for the TI-84 on my computer. If you would like the information on how to get this calculator, just visit MrKrauseMath.com. There's a link there. And if things should happen or change, probably look in the show notes at some point. There'll also be a link. Just go to education.ti.com or ti.net. But anyway, there's a link there. You'll be looking for the TI Nspire software. It's about $27 for the year, or if you want, you can just buy it outright for $112. All right, let's get started. I won't use the calculator too often because I don't necessarily agree with using the calculator. Oh, this one's going to be a little bit different. Okay, I got to go page by page. Page 2, which means every time I go to a new page, I gotta set it up. Kind of a pain in the ass. Okay, next. So we are looking for, in this case, we are looking for data collection that will be, you're checking the viewer preferences for local news programming in Buffalo, and you want to collect the data that's appropriate. Well, very quickly, let's go through these. A census means you're going to ask everyone. If you take a census, that means you ask everyone. Probably not what you're looking for. If you take a survey, that means you're going to send out 100, 200, 1,000, I don't know, it depends on what the viewership is for that area. You're going to send out a certain number of questionnaires or things and asking people about what their needs are for viewing preferences. Looks like that might be the right answer. Let's keep going. You're going to observe. No, it's not. It doesn't even say newspaper or television, but I'm relatively certain there's no way you will be able to observe what the population is doing and what's going on in their head about their news preferences. And a controlled experiment, well, if you could think of a controlled experiment to figure out what people want for their news, for their news preferences, you're a much better person than I am. This is just one to know that you are, really it should have come down to one of these two, but nobody uses a census. That's why the United States government only does them every 10 years, because you have to ask everybody. So we will do a survey to just get a sampling of what people are thinking, to use that as our data to drive our decisions. And that's how almost everything's done in the society, through decisions. What is the number of degrees in the ankles whose radian measure is 8 pi over 5? The easiest way to handle these ones is to remember that pi is the same as 180 degrees. So what you're going to do is you're going to replace this. Now I know most of the teachers will say multiply by 180 over pi. Really what in effect you are doing is you're just going to replace pi with its degree equivalent, which in this case is 180 degrees. So we'll replace that with 180 degrees. I will take out my calculator, which I believe I have on the last screen. Good. And I will attempt to do this. And I will do 8 times 180, enter, divided by 5. Anytime you're doing fractions, it's usually in your best interest to do that. Now, this silly calculator will, oh, it gives us 288. Okay, perfect. So the answer is 288. Again, I think most teachers would probably, and when you talk about it at the beginning, you're just going to say, okay, you're going to multiply by 180 over pi. Notice the pi's cancel each other out. So really what you're doing is replacing the pi with 180. All right, moving on. 1-to-1, we're looking for. The two things that are key in this is 1-to-1 and onto. Now, in this particular problem, there are a number of these that are 1-to-1. 1-to-1 means for every input, there's exactly one output. So this is 1-to-1. This is 1-to-1. Nope, this is not 1-to-1. This is not 1-to-1 because this goes in two different places. So no, this one can't be anything. This one is 1-to-1, and this one is 1-to-1. For every one, 1-to-1 means for every one this way, there's one backwards as well. So I probably misspoke that the first time. So basically what I'm saying is A goes here, and 3 goes back here. So that's 1-to-1. The 3 does not go any other place. You can always do plot these things. Now I'm not sure how you plot A. I guess you do A1. It is A1, B2, and C is also 1. This function is, it's a function, but it's not 1-to-1. Where is my pointer? This is not a 1-to-1 function, so I misspoke. It passes the vertical line test, but since it does not pass the horizontal line test, it is not 1-to-1. And when I should have realized it. I checked A quickly, and I didn't check B. B goes to 1, and C also goes to 1. So that makes it a function. In order for it to be 1-to-1, then you can only have one arrow going here. Notice I can't make a decision whether 1's going to come back to C or 1 is going to come back to B. So this is not 1-to-1. These two down here are in fact 1-to-1 functions. Onto just means that in what you need to remember as far as the Regents exam goes is every member of the range will be used. And in this case, notice this 2 is not being used. But over here, every member of the range was being used. And so for onto, you want to make sure that every value that's in your range was used in some place. So for 1-to-1, these arrows point to one and only place, and these arrows backwards, if you were to draw these backwards, only point to one place. That's 1-to-1. And onto means you want to make sure that all the range values are being used. This is going to be kind of a pain to have to, oops, get these to blow up every time. Okay. So you're looking at the 8 terms now here. Now, it doesn't tell you here whether or not it's a geometric multiplication or arithmetic adding sequence. You're going to have to kind of figure that out. So if you look at these, they go 3, negative 12. I can either subtract 15 or I can multiply by negative 4. If I go to positive 48 next, then we are not subtracting 15. We are multiplying by negative 4. So this is a geometric sequence. Now I could, if I wanted to, list these all out. Now this would be a pain. I think it's 3, negative 12, plus 48, minus 192. I think it's plus 768. Don't hold me on these. I think these are what I have written down. Minus 3072 plus 12,288 minus 49,152. And you could add all those up. But what if it said 100 or 50th? You'd be there for the entire test trying to do that. You don't want to do that. So we know it's a geometric sequence. And we know it's because it's multiplying. So we're going to use this summation thing that you've learned. Let's see if I can draw this. That's not bad. And we're going to start n at, I think I started my n value at 0 and I went to 7. That would be 8 numbers. I'm sure there's a way to do it another way. So I do negative 4 n times 3. Actually, I think the way they do this, let me see if this works in class. This would work, by the way. This would give you this geometric sequence. If I type this in my calculator, I would get, let me put it over here. Let's see, I think I can get to it like this. And down here I could just put x or n. I just choose n in this case. n 0 7. I'm going to have to use parentheses here. Negative 4, because if you don't do 2 negatives in parentheses, especially when you're dealing with exponents, you will not get it right. To the n power. And then times 3. Negative 39,321. There it is right there. Choice 3. And that is in fact the right answer. But I think the way they do this, let me get rid of this, let me get rid of this. I think most teachers will teach it this way. You'll start at 1 and you go from 1 to 8. And then here you do n minus 1. So let's see if that works. I'm pretty sure that's the way we do this one. Let's just get the up arrow. And we'll retype this line and we'll change this to a 1. It really doesn't matter. We'll change this to a 8. And we'll change this exponent to n minus 1. We should get the same exact value. There it is. Negative 39,321. Same exact thing. Most teachers will use this. I think when I was going through it, I chose n, but most teachers will do this one. Okay. Okay, so this might be a preference of how your teacher goes about choosing this. I choose to make everything a fraction, and I choose to get rid of this thing by, you're basically multiplying by 1. But you're going to do so by multiplying the numerator and denominator both by the lowest common denominator. In this case, the lowest common denominator is, first of all, you all should be yelling at me for putting x's underneath there. The lowest common denominator in this particular case is x squared. So I'll put 1 underneath each one of these. And I'm going to put an x squared next to each of these. Okay. Then I'm going to go through and simplify. Well, nothing simplifies on this. I end up with just x squared minus one of these x's cancels with one of these x, and it leaves me 4x on the numerator. So no more fractions on the numerator. Got rid of that problem. Down here I will get x squared. One of these x's cancels with one of these x's. I get minus 2x. And then this x squared cancels with this x squared and gives me minus 8. So now I have to use one of my favorite tools, which is just to factor. So I'll take out an x, and I'm left with x minus 4. In the denominator, I'm going to factor this. They have to multiply to negative 8 and add up to negative 2. Well, that's very simply x minus 4 and x plus 2. Now I'll go back to start and divide out common factors. This minus 4 cancels with this. And it leaves me x over x plus 2. Choice 2. Yay! Alright, now we're doing some sine curves. Okay. So, since this does not start here and go out, which would be the sine curve, we know that since it starts at the bottom or the top, that it's going to be a cosine curve. So it can't be these. Unless, of course, it has a horizontal phase shift, and then it could be a sine curve. But in this case, none of the solutions in the answers had horizontal phase shifts. The amplitude is 2. So the amplitude in this case is 2. Well, that doesn't really help us out. Both of these have 2's in front. And it starts down here at the bottom, which means that they both start out at negative 2. So the fact that it started down here and not at the origin told us it was probably going to be a cosine curve. But that's about all you get from that. So now I got to go through and figure out the period. How long does it take to finish one complete cycle of this curve? Well, to finish one complete cycle all the way up and all the way back down and back to my starting point takes pi. Or another way to say this, it will complete 2 cycles in 2 pi. Well, this number right here, the B number, tells us how many complete cycles it will complete in 2 pi. So choice 3 is the right answer. Now, another way you could do this is to figure out the period, and give me an opportunity to talk to you about period. The formula for period, and remember, the definition, or for you guys, or what you need to remember is the period is the time it takes to complete one complete cycle of the cosine curve. So that formula is 2 pi over b. So 2 pi over, and in this case the b value is 2. Those cancel, and I'm left with just pi. So it should take pi to finish one curve, and we did talk about that. All the way up and all the way back down over here to finish one curve. Alright, done with that page. Just a few left, kids. Why does it do that to me? Alright, blowing up. Okay, so you remembered at some point when you've got the inequalities, or the absolute value inequalities, that you're going to have to solve 2 equations. You're going to have to solve the original, 2x minus 1 greater than 5, and do not change the left side of the equation. Do not change the absolute value part of the equation. That stays the same. Everything else changes. We want it greater than positive 5 or less than negative 5. Those are the 2 things you need to solve. I'm going to subtract, add the 1 over. I get 2x is greater than 6, or x is greater than 3. That leaves us not these 2. Now I'm going to solve this part of it. I'm going to add 1. I'm going to show you this work because I want to make sure you don't make this mistake. So I get 2x is less than negative 4. Divide by 2 and I get x is less than negative 2. Choice 1. Alright, moving on. Range. Well, I'll tell you both. I'm going to tell you both. First of all, range is the y values. We're only looking for the y values. So I don't even care what those are. We're only looking for the y values. And in this particular case, the highest y value is 0, and it goes forever and ever and ever down to negative infinity. Or in other words, the y values have to be less than, or they could be equal to, 0. Just for fun, this could have been written in interval notation, and interval notation is kind of tricky here. It's from negative infinity all the way up to 0, but including 0. And that could have been written in interval notation. Man, done with that page. All right, so sine of 90 degrees, or theta plus 90. So anytime you are given one of these equations where it's sine and it's got a plus or a minus in it, that is going to say to you, go to your formula sheet and remind yourself, and I think it's on page 23. There it is. It's not always on page 23, but in this case it was. So I want the sign that has a plus sign in it. And that would be this equation right here. So it's sine A cosine B, cosine A sine B. So let me go back. I don't remember what page I was on. Nope. I guess I'm on page 5. It shrunk again. Okay. So this would be, let me get my red pen out. Sine of the first thing, which is theta. Remember, this is A and this is B. Cosine of 90 plus cosine of A, which is theta, sine of B, which is 90. Okay. You really need to have your trigonometric values, degrees, sine of 45, sine of 30, sine of 60, sine of 90, sine of 0, all of those you need to have memorized. It is not great not to memorize these. You can always use your calculator to figure it out. But you should know that the cosine of 90 is 0. And 0 times whatever this is just going to go away. The sine of 90 is 1. And 1 times anything is anything. So 1 times cosine is just cosine. And choice 4 is your answer. Make sure I'm not giving you the wrong answers. Okay, good. Moving on. That's it. That's all you have to do. Inversely proportional means that in your class you probably learned x times y is equal to some k value. In the first one, 2 times 3 equals 6. Oh, let me go back. This is still true. I just misread the question. It's inversely proportional to the square of x. Not square root, but the square of x. So we're going to square x times y and get k. So in this case, I get 2 squared times 3. And that's really 4 times 3 or 12. In this case, I'm going to get 4 squared times 3 fourths. 4 squared is 16. 16 times 3 fourths. You could use the calculator. I choose not to. Is also equal to 12. So now I'm going to do 6 squared times d. And if they're inversely proportional, they should also equal 12. Well, this is really 36d. So what I have to solve is 36d equals 12. Divide by 36. Divide by 36. And I find out that, 36, that d is equal to 12 over 36, which is not one of the answers, but this reduces to 1/3. So 1/3 is one of the answers. I'm going to pause this. I'll be right back in a second. Well, I'm back. I don't know how long of a pause that was for you. I had to take a couple second pause. I forgotten. I'll show you in a second. We got to get this to the nearest minutes, okay? And I use the TI Nspire. I think the TI 84 actually is a little bit easier for this one. I'm looking for angle S. This is my theta here. And you need to remember your trigonometric ratios. Some old horse caught another horse tripping on alligators, or whatever you learn. If I label this diagram, if I'm looking for this is the opposite side and this is the hypotenuse. So it should be clear that I want to use sine. So you need to do sine of theta is equal to 8 over 17. But I don't want that. I want to somehow get the sine onto this side. Now, you know, you will have gone through the theoretical lecture of how to do that in class. I'm not going through that. You should know by now that you need to use the inverse sine function, which is the sine -1 of 8 divided by 17. But if I do that on my calculator, first of all, I want to make sure that I get the right answers. You'll notice if you just hover over this, that it will tell you what degree mode you're in. So if you just clear that and you hover right over that, you'll see that I'm in radian modes, and that's really not going to help me when I'm looking for degrees. So the first thing I want to do is go into the home. I want to go down over here into settings, and I want to go into document settings, and I want to change from radians to degrees. Otherwise it will not work. And choose OK. Now I'll go back into my calculator. Now I'm not sure what I'm in right now. Just hit enter. I need to do the sine, so I want to do the inverse sine, which is you hit this trig button and you go to sine of 8 divided by 17. Well, that actually is not going to be very useful, because that will just give you the decimal value, and that looks like it's not in the right mode. That should give me 28 or 61, and it did not. So notice I'm still in radian modes. All right, go back into here. Sometimes you have to do this. I'm not sure why they make you do this garbage. We'll click into degree mode, and we'll choose make default. That makes it the default for anytime you're going to do any calculations. Now I go into calculator, and it should tell me I'm in degree mode. If I hit the up arrow, I mean, clearly 0.489 degrees. It doesn't make any sense, right? It should be either 28 or 61. In this case, it's 28. So at this point, I already know that it's not one of these two. But I still need in degree minutes seconds, and the clearest way that I've been able to find this, and the only way I've been able to find this, what I was just looking for to see if there's a better way to do this. I'm going to keep looking. I hope there is. But I go into catalog. Now you can hit the scroll down button, but you're going to be there for quite a while because there's a lot going on. Or you can just start typing. If I type in D, it takes me to the D's. If I type in M, oops, go back to the D's. I thought you could just type in DMS, but whatever. I typed in the D's. At least it gives me down here. You'll find here it is. This arrow means take whatever previous calculation was done and DMS it. Degree, minutes, seconds. And we'll just double click on that and hit enter. So that says take the answer and DMS it. And we hit enter. So I get 28 degrees, 4 minutes, 20.953 seconds. But we need the 28 degrees, 4 minutes. That will give us choice 2. All right, that's it for that one. Okay. Which order pair is in the solution set of this? So this first one, let me just do this. It's y squared minus x squared. And we really want that to be negative 32, because if I bring this 32 over, I need that to be negative 32. Well, if that's going to be negative 32, then wouldn't it make sense that x would be bigger than y? Now, bigger is a relative term, With negative or positive, it doesn't matter which one, it's going to be bigger. So x is not bigger than y here. This would be, y is much bigger. This would be 36 minus 4, which would be positive 32. That would not give us 0. This one's bigger. 3 squared is 9. 9 minus, or wait, 1 squared is 1 minus 9. It's not going to give us 32. So it's clearly not one of those. It's probably not this one either because it's a small number. So if I'm going to check, I'm going to check this one first. If I put in x squared as being negative 6 squared, that's positive 36. Excuse me. I'm going to put in negative 6 in here for x. That gives me positive 36. I'll put the negative 2 in here for y. That gives me positive 4. 4 minus 36 is in fact negative 32. But I want to really make sure that I'm right. So I'm going to check it in this one. 3 times negative 2 minus negative 6. Does that in fact equal 0? Well, this is negative 6, and 2 negatives make a positive, and positive 6 equals 0. So there's my answer. All right, page 6 finished. Only a few left to go. All right, there's a couple of different ways to handle this problem. I'll do it straight from the formula. A equals P e to the RT. So, common mistake. Probably the most common mistake is not using the right percentage. So let me get all the information down I have. We want to, where is it, double our money. So I've got everything I need. The rate is 5%, but as a decimal, and this is where the common mistakes are made, that's 0.05. I don't know the years. My principal amount is 500. What we're looking for is the time it's going to take. So it's a double. So really what I want to do is I want to make $1,000. I want to make $1,000. So my final result is going to be $1,000 equals 500 e to the rate, which is 0.05 times t, which is time. Now, quite simply, if I wanted to, I could just use the answers to solve this. Really what I'm looking for is if I divide by 500, I want e to the 0.05 t to be equal to 2. I'm going to use logarithms. If I take the natural log of both sides, so I get the natural log of 2, because the natural log and e are inverse functions, I get the natural log of e to the 0.05 t. If you remember, when you do logs, these come out front. So I get natural log of 2 equals 0.05 times t. The natural log of e. Well, let's go back and take a look real quick. What is the natural log of e? You all should know that. If I do the natural log of e, it's really e to the 1. I should just get 1. So really this just goes away. So to solve, I'll divide by 0.05. And if I go back to my calculator and I take the natural log of 2 and I divide by 0.05, I get 13.86 something. I'm looking at my answers. 13.9 looks pretty good. I want to check it. I want to make sure I'm right. Very simple to check. We'll do is type it in. 500 was my initial investment. E to the 0.05 times, and the answer we picked was 13.9. So it should be close to 1,000. There it is. Very close to 1,000. And there's my answer. This next question is a rather tricky question. Very tricky question, if you ask me. I'll bet there was a lot of kids that missed this on the Regents exam. You'll have to remember that negative exponents have absolutely nothing to do with being negative. So what I'm going to do is I'm going to convert all these first to what they really are. The first one is 6 over n squared is less than 4 over n. The second one is n over 4 is greater than negative 6 over n. The third one is 6 over n is less than 4 over n. That looks like a pretty easy one to check right there. 4, probably don't know that, is 4 over n is greater now. Now this one's going to change a little bit since the 6n is in parentheses. It's 1 over 6n. Now the trick to this one is which is always true. So you should try positive and negative numbers. Let's say I put n equal to 2. Well, originally this would be 6 over 4 is less than 4 over 2. That's true. That's true. But what if I made it negative 2? Well, this would be 6 over 4 still is less than 4 over negative 2. And that is not true. So this does not work. So let's try 2 over 4. That's 2 over 4. That's a half. Is that greater than negative 6 over 2? And absolutely it is. It absolutely is. That's 1/2 is bigger than negative 3. But if I change this to a negative, this is negative a half. Is that greater than positive 3? Nope, it is not. Again, 6 over 2 is 3. 4 over 2 is 2. Is 3 less than 2? Nope. Oh, that's the right answer, 3. I'm not sure why I got the wrong answer. Let me think for a second. What am I doing wrong? Oh, man. I misread the question. It said right here, if n is negative. That's a common mistake made. I knew this was a tricky question, and I forgot that it had this negative part in here. So clearly I should not even have been checking any positive. I should be checking negatives, because when this was positive, this is actually not a true statement. But when n is negative 2, this would be negative, and this would be also negative. But negative 3 is smaller than negative 2. And that's your answer. And I can check it again in here too. Put in negative 2. This is 4 over negative 2, which is negative 2. Is that greater than 1 over negative 12? Well, remember, when you're working with negatives, everything's backwards. Negative 2 is much smaller than negative 1/12. All right, moving on.